Hello class, this is Math 1440. We're going to go over section 8.7, which is double integrals. And here's what we want to do. Calculate the volume under the surface, z equals, by the way, z is just output. It's the same thing as f of x comma y. So I could have written f of x comma y or z, in this case I wrote either one, is equal to 3 plus x squared minus 2y. So that is our function. I put it in a red box just so we can see it. Okay, over the region R. So this region R is in the xy plane. And the region R is defined by 0 is less than or equal to x is less than or equal to 1, and negative x is less than or equal to y is less than or equal to x. So for our solution, the volume V, which is what we're looking for, is given by a double integral of that function over R. So I've got thus V is equal to this double integral over the function, and now my brother's going to tape me while I do this problem. And my advice is go to khanacademy.org and also, visit the WebAssign video, because I think when you see the videos, this makes a lot more sense, because we're talking about three-dimensional figures. And that's hard to understand when you're looking at, a page of notes. It's better to see the video, to see that 3D picture of the surface that we're trying to find the volume under and above the region R. Okay, so here is my brother. Okay, so the first thing is we have to identify what these limits of integration are. And then is it going to be dx dy or dy dx? So sometimes the order of integration doesn't matter, but you would have to change these limits accordingly. But in this case, the order does matter. So notice this is a constant. So because x goes from the constant 0 to the constant 1, whereas y is in variables, we must have we must have this inside integral with the variable endpoints. So we're going to go from y equals negative x to y equals x. And then the outside integral must have constants, because ultimately we're going to do the outside integral last, and we want a number answer. So we got to have number endpoints here. So you must have x equals 0 to x equals 1. So on the outside integral, they must be constants. So sometimes you're going to see constants and variables. So the variables go on the inside. Okay, and now since my inside integral is in terms of y, we're going to write dy, and my outside integral is in terms of x, so write dx. Okay, and now how do I evaluate this double integral? Here's the best way to do it. Look at the inner integral first. So notice the inner integral goes from y equals negative x to y equals x. Since these limits are in terms of y, that's why I knew to write dy here. And then when I get this answer, I'm going to plug that into the outside integral from x equals 0 to x equals 1, and the outside integrals with respect to x. So the first step is to evaluate this inner integral. So you always do the inner integral first. So, and you don't have to write the y. You could just write negative x to x, but I find that's more clear if you write y equals, because we're told y is going from negative x to x. Okay, so I'm going to continue writing y equals negative x to y equals x. And then you write your function here, 3 plus x squared minus 2y. Parentheses are optional, dy. So that's what I want to do first, this inner integral. Okay, so we're integrating with respect to y. So what's the integral of, and then we're just going to go term by term doing the integrals. So the integral of the 3 dy is just going to be 3y plus, this is just a constant because we're integrating with respect to y. So x's are constants. So what's the integral of some constant with respect to y? It's going to be that constant times y. Minus, and now here we got a y term. So what's the integral of 2y dy? It's going to be 2 times, and then by the power rule, think of y as y to the first. So you increase the power by 1 and then divide by that number. So that's the integral of 2 times y dy. It's going to be 2 times y squared over 2. And then we're going to evaluate from y equals negative x to y equals x. I'm going to cancel those 2's to make life easier. Okay, always input the top limit first. So wherever I see y's, I'm going to plug in x. So this is now going to become 3x plus, the x squared is just a constant, but in place of y, I'm going to write x times x, this is all multiplication, minus, instead of y being squared, y is equal to x, so it's going to be minus x squared. So I'm done with that upper limit. Now I got to go minus parentheses, and now we got to input this lower limit. So you always begin with the upper when you're doing your substitutions. Okay, so now wherever I see y's, I'm going to write negative x. So it's going to be 3 times the negative x, that would be my 3y, plus x squared times, instead of writing y, we're going to write negative x, minus, and then I'm going to write in parentheses negative x squared, because y is equal to negative x. Close the parentheses. Okay, let's simplify this. So this becomes 3x plus x squared times x to the first is x to the third, because you add the exponents, minus x squared, minus parentheses. Let's simplify what's in the parentheses here. This is going to be a negative 3x, and then a plus times a minus is a minus, and then it's going to be x cubed, because x squared times x. And then you got to do the work in the parentheses first. What's negative x all squared? It's a positive x squared, but now it's going to be a minus x squared. So it's tempting to go, oh, 2 negatives make a positive, but by order of operations, you got to do that first to get x squared, and then it's going to be minus x squared. Let's simplify further. So this is going to be 3x plus x cubed minus x squared. Distributing the minus, I get plus 3x plus x cubed plus x squared. Let's combine like terms. I like to put standard form, so my highest exponent is 3. So what's an x cubed plus another x cubed? That's 2x cubed. And then I'll go to my square terms. The minus x squared cancels with the plus x squared. And then I'm left with 3x plus another 3x for a plus 6x. So this is my answer for the inner integral. So now what you do is you go to your outer integral, and then we're going to be done when we do this outer integral. So the outer integral is going to be the integral from x equals 0 to x equals 1 of this answer that we got from the inner integral, 2x cubed plus 6x. I'll put parentheses around that. And notice with the outer integral, you got to write the dx. We're almost done here. So this is going to equal, and this is the, okay, let me continue over here. My brother got tired of holding the phone camera. So now we got this integral to do. So by the power rule, it's going to be 2 times x to the 4th over 4. So let me write that down. 2 times x to the 4th over 4 plus 6 times x, the integral of that with respect to x, pull out that constant 6, and the integral of x dx is x squared over 2. So let's see what I wrote here so far. So the outer integral is going to be that. And now because this is a definite integral, instead of writing plus c, we draw this evaluation bar. And we're going from x equals 0 to x equals 1. Okay, so now this is going to equal, don't forget those equal signs, and 2/4 reduces to 1/2. So let's just call that x to the 4th over 2 plus, and then here 6 divided by 2 is 3, so I'm going to write plus 3x squared. And again, we're going to evaluate from x equals 0 to x equals 1. So this is what we have. And now, like before, you got to input the x equals 1 first. So 1 to the 4th is going to be 1, and then we got over the 2, plus, and then when x is 1, 1 squared is still 1, 3 times 1 is 3. So I'm going to write 1/2 plus 3. So this is going to equal 1/2 plus 3 minus the expression, And now we're going to input the 0. So in this case, when x is 0, this term goes to 0 because 0 to the 4th divided by 2 is 0, plus this term goes to 0. So I'm just going to write 0 here. You don't have to write it twice. Once is good enough. And my final answer is going to be 1/2 plus 3 is 3½ So that's my final answer for the volume. Or if you want to write it as an improper fraction, 2 times 3 is 6 plus 1 is 7/2. So either answer is good, 3½ or 7/2. And that's it for that problem. All right. Have a good rest of the weekend, everyone. Bye-bye.